IGCSE worksheet. These are the 5 subtopics that are included in this worksheet. Here we go. Question number 1. Write down the probability that a marble picked at random from bag A is black. There are only 2 marbles that are black, so we're going to say 2 out of a total of 5. That's your answer. Toby says you are more likely to pick a black marble from bag A than bag B because bag B has more marbles, so there's a high chance. Is Toby correct or not? The only way we can know that for sure is once we calculate probabilities for both. So what is the probability of selecting a black marble from bag B? B over here stands for black. So that's 5 by 13. What is the probability of selecting a black marble from bag A? I should note that down somewhere over here. This is bag B. This is bag A. We already have the probability as 2 by 5. Now you cannot compare them easily until unless you have the denominators which happen to be the same, or you convert them into a fraction. Decimals. They're already a fraction. So let's try to convert that into decimals. If I were to divide 5 by 13, that would come out to be, since in IGCSE you're allowed calculators, 0.384, and 2 by 5 would become 0.4. So is Toby correct? No, because probability of selecting a black marble from bag A is way higher. It's little higher. Or the other way that you can do that, in case you're watching it, those of you who are doing O levels, you can take the LCM of 5 and 13. So basically you can comparing 5 by 13 and 2 by 5. Now what's the LCM of 13 and 5? That's 65. So what am I going to multiply 13 and 5 with? If you do not know the concept of LCM, you're basically supposed to write the denominators like this and try to divide it up until the time you get 1 and 1 in their place. So I'll divide it with 5. Now 5 doesn't fit into 13 any number of times. However, it does divide 5. And then I can choose 13, 1 and 1. 13 into 5 gives me my LCM, that's 65. Now what do I multiply 13 with so that it becomes 65? I'll multiply it with 5 over here, and I'll multiply it with 5 in the numerator as well. Hold on. Five over here and 5 over here. What do I multiply 5 with to make it 65? I'll multiply it with 13 over here and 13 over here. Now 5 into 5 is 25. Watch closely. And this is 26 over 65. Now that the denominators are same, I can simply erase them and just compare the numerators. 25, let me keep them for sake of clarity. 25 and 26. Now the probability of getting a black marble from bag B is 25 by 26. And whereas the probability of getting a black marble from bag A is 26 by 65. So that's slightly higher. Once again, it proves the same point. So is Toby correct? No. Why? Because probability of getting a black marble from bag A is higher. You can write that down. Toby adds some marbles to bag B. Okay. The probability of picking a black marble at random from either bag is now the same. So he's adding some number of marbles in both, just to bag B. He's adding some marbles to bag B. Now the probability of bag B was 5 by 13. The probability of bag A was 2 by 5. Right? To work out the smallest number of black marbles and white marbles, he adds to bag B. How can two fractions be the same when they have different numbers? 1 by 2. Is it equals to 2 by 4? Is it also equals to 3 by 6? Let's see. If I multiply 1 with 2 and 2 with 2, don't I get 2 by 4? And if I simplify it, don't I get 1 by 2 again? What if I multiply 1 with 3 and 2 with 3? Don't I get 3 by 6? And if I simplify it, don't I get 1 by 2 again? Similar is the case over here. I am supposed to see, if I multiply both the numerator and denominator with 2, what do I end up with? I end up with 4 by 10. That's close, but not all the way there. What if I multiply the entire equation, the fraction with 3? That is 6. by 15. Now this is relatively close, and if you were to understand this, they're asking us to add some white marbles and black marbles over here so that it has the same probability of selecting black marbles from bag A. Remember, we had probability of selecting black marble from bag A was 2 by 5, right? They're saying we need to add some number of marbles in bag B, black and white both, so that it simplifies to this fraction over here, exactly the same fraction over here. We are already at 5 by 13, and we just found out that if we multiply this entire fraction by 3, we get 6 by 15, which is very close to this number 5 by 13. What if we add one white marble? I'll draw it over here. What if I add one white marble? So we'll keep it hollow over here. Give me a minute. Let's add one white marble and one black marble. Now we have the total has jumped up to a 15. And how many black marbles do we have? Let's count them, in fact cross them out one by one. 1, 2, 3, 4, 5 and 6. So this has jumped up to 6. 6 by 15. Now 6 by 15 is that same magic number that we were aiming for. Why? Because if we simplify this way 3, we get 2, and 3 5s are 15. That's the same number that we had over here. So that's exactly what they're asking. Work out the smallest number of black and white marbles that you can add to bag B so that it has the same probability now as bag A. Probability of what? Probability of being able to select a black marble. And the probability of being able to select a black marble from bag A was 2 by 5. So we had to add a certain number of marbles to bag B so that probability comes out to be the same, and it just did. Paul has a set of 8 cards, each with the number written on it 1, 2, 1, 1, 2. It has 3, 3, 4 and 5. One card is taken at random, write on the probability that the number is 1. Take a look, there are 2 ones, we're going to say 2. And how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8. 2 by 8, or you can also write it as 1 by 4. Right? The second part says probability that the number is odd. How many odd numbers do we have? 1, 2, 3, 4, 5 and 6. So that's 6 by 8. Or that simplifies 2. If we cancel it out with 2, we get 3 by 4. A prime number. A prime number is a number which is only divisible by itself and the number 1. So prime number, this is prime, prime, and this is prime. So how many prime numbers do we have? 1, 2, 3, 4 and 5. So the answer for this is 1, by the way, is neither prime nor composite. So the answer for this is 5 by 8. And a number less than 6. Any number that you select out of these 8 cards is going to be less than 6. So it's going to be, the answer for that part is going to be 8 out of 8. Because that's 100% for sure. That's what we discussed. Probability scale is something that we discussed in the first part of this series as well. Go back and look at it if you don't understand what 1 means. 1 is basically 100%. Surya makes 30 flags and 11 are pink, 7 yellow, 5 blue and 4 silver, 3 green. Probability that she draws or takes a pink flag, that's 11 by 30. Not blue. Well, blue are 5. So we can say 1 minus the probability of selecting a blue. 1 represents 100%. Probability of selecting a blue is 5 by 30. If you take the LCM, there is a 1 over here. You multiply it with the 30 to make it this 30 as well. Multiply the numerator with 30 as well. 30 minus 5 over 30, and that gives you 25 by 30. Now you might be wondering, why did I go through all of this hassle, whereas I could have just added up these numbers 7, 11, 4 and 3. They would have given me 25 as well. Well, you're correct. That's another way of doing it too. Red. But remember, Cambridge requires you to be able to do this technique as well, where you subtract the previous answer or another answer from 1 to get the current answer. Red. What is the probability that she takes a red flag? There are none. There are no red flags, so 0. 0 out of 30. which is 0. The diagram shows a fair 8-sided spinner. It has numbers, some random numbers on it. The numbers on the spinner are these, which are already mentioned. The spinner is spun once. Write in the probability that spinner lands on the number 7. There are 3 7s, so 3 divided by 8. 1, 2, since it's an 8-sided spinner, but let's confirm it as well. 1, 2, 3, 4, 5, 6, 7, 8. Yes, 3 by 8. A number greater than 2. What are the chances that you will get a number greater than 2 once you randomly spin it? I don't think there's any number. I don't think there's any number less than 2. Every number out there is greater than 2. So that's going to be 8 by 8, which is equals to 1. The spinner spins 160 times. At the start, we were only spinning it once. Now we're spinning it 160 times. Work out the expected number of times the spinner lands on number 7. The easiest technique is just to find out. Just take the previous fraction, multiply it once with 160 because you're carrying out the experiment 160 times, and simply start simplifying. 20 into 3 is 60. Work out the expected number of times you're going to get number 7. It's 60 now. Simple. So basically what you're supposed to do is multiply the probability of getting it once and then multiplying it with the quantity of times you're spinning it. Mahika records 120 students from year 1 and year 2 travel to school. Each student walks, cycles or travels by bus. 48 students in year 1, 77 students walk, 5 students in year 2. It's pretty confusing, but let's go to the next question and try to understand next part and try to understand what it's referring to. Well, they're asking us to fill a table, and I think in order to fill this table it will be very important that I pull this table up. Okay, since it says 48 students are in year 1, that means if I were to add this entire year, at the end I'll be able to say there are 48 students, right? 77 students walk. The total number of students who walk are 77. They haven't told us whether they are in year 1 or year 2. So we'll assume that's the total number of students. 5 students in year 2 cycle. Now year 2 is this one, cycling is this one. So where they collide, that's where we need to fill out 5. So this is 5. 36 students travel by bus. 36 students travel by bus. Now where is, okay, once again this has to be the total number because they haven't told us whether it's year 1 or year 2, and 4 by 9 of the students who travel by bus are in year 1. So those who travel by bus are 36. 4 by 9 of means multiply. 4 by 9 comes down as it is. Now we're trying to change it into an expression. 4 by 9 as it is, of becomes multiply, and 36 are the number of students who travel by bus in year 1. If I were to simplify this, 9 ones are 9, 4 is 36, 4 into 4 is 16. 4 by 9 students who travel by bus are in year 1. So this number comes out to be 16. How? Because they're mentioning year 1 and they're also mentioning bus. So this has to be the number. Now we don't have any other values to figure out from the statement that they've given us. What we're going to do is trying to figure out how to find rest of the columns. Here is what we're going to do. Now if we were to look at this column over here, some number must have been added to 16 to get 36. So we're going to go the other way around. 36 minus 16 comes out to be 20. So this value that I'm figuring out from the table alone, I'm going to be labeling them or writing them in orange. Now this number, once again, 48 must have been added to another number to get 120. So we're going to subtract 48 from 120 and we get 72. Right? So we're getting places. Now what else can we do? Is there anything else that we're given? We had 5 statements, 1, 2, 3, 4, 5, and we figured out 5 numbers. Yes, now we need to work row wise. Take a look at this. In year 2, 5 plus 20 plus something, some number over here, x, gave us 72. So what should we do for that? We will subtract 5 and 20 from 72. What do we end up with? 47. So this number that I marked as x, this is going to be 47. Similarly, if we were to look at this column, you'll notice something has been added into 47 to give us 77. 77 minus 47 gives us 30. This number must be 30. So we're getting really close to figuring out the entire table. Now what we can do is, the total is 48. 30 plus some number plus 16 gives us 48. What we can do is subtract every number that we have from 48. 48 minus 30 minus 16 is 2. So there's just this number, a very small number of 2. I'll show you what I mean by this. Now if you add 30 plus 2 plus 16, you will get 48. Let's check. 30 plus 2 plus 16 gives us 48, right? Similarly, the cycling total has to come down over here. So 2 plus 5 is 7. Remember, this column is this row is representing total. So we figured out the entire table. I know it was a little tricky. Now the question says, one of the 120 students is chosen at random. Work out the probability that this student does not travel by bus to school. Work out the probability that the student does not travel by bus. Now, if he doesn't travel by bus, he is either walking or cycling to school. So that's 77 plus 7 over a total of how many students do we have? 120. Remember? So 77 plus 7, and that comes out to be 84 divided by 120. You can always simplify this number or keep it as it is. Question number 6. Bag A contains 3 black balls, 2 white balls. A ball is taken at random from each bag. You have to select one from each. Show that the black ball is more likely to be taken from bag A than from bag B. Once again, work out the probability of taking a black ball from bag A. This is bag A. So we've got 3 divided by 5. Now what is the probability of selecting a black ball from bag B? That's 1 by 4. This comes out to be 3 by 5 is 0.6, 1 by 4 is 0.25. If you know your basic fractions, you will be able to identify this. If you do not have a calculator, you can always use the LCM method. Show that a black ball is more likely to be taken from bag A. Well, we've just shown that because this 0.6 is higher or greater than 0.25.